discuss the physical features that we'll be talking about throughout this section on Northern California. And we have our Earth view, which we can see a particular pattern. We can see a change in the colors that is associated, of course, with precipitation amounts, and then that, of course, relates to vegetation. So that's one of the characteristics we're going to see here is as we go away from the coast, definitely gets drier, with the exception of this particular mountain range right through there. Let's go ahead and do the terrain view so we can see a little bit more as far as the particular mountainous areas. So first off, we have our coast ranges, the northern coast ranges, this would be called. Think about the California, in terms of California, the northern coast. These would be the southern coast. It's going to be more applicable to our Southern California discussion. Then we have the Sierra Nevadas, and in between is the Central Valley. In the Central Valley, very clearly you can see the Central Valley area. This Central Valley area actually was, just an extension of the Pacific Ocean. As sea levels, just imagine being a little higher, essentially the water would come in through here, and all of this would be then underwater. Further, a lot of erosion from the Sierra Nevadas, erosion, transportation, and deposition, a lot of that deposition, a lot of that sediment that was previously mountain, has essentially been eroded down and is, over time, filled this huge trough, or this huge, what's called a narrow bowl, with sediment. So that's also how to kind of cause it to fill in, to adding to this particular very flat feature. This particular area here is the Sacramento Valley, and down here is the San Joaquin Valley. The San Joaquin Valley we'll talk about later on when we talk about Southern California, but Sacramento is essentially the divider, and that's because of the river. The Sacramento River flows into, go figure, Sacramento, where the San Joaquin River flows into Sacramento, and so that's why it's prominent. Up here in the extreme northern part of California, it's kind of this mountain range, is kind of this conglomerate of different mountain ranges. They call it the Klamath, K-L-A-M-A-T-H mountain range. This up here, not particular, the same pattern we see throughout much of the rest of the state, in which we have mountains, valley, mountains, as we go from west to east. Let's go ahead and use our geocontext, our good friend, our topographic profile creator, to look at particular patterns we see in the topography and try to further pinpoint some landforms. So I'm going to go from, let's just go ahead and go from over here out into the water, the Pacific Ocean, across to the Sierra Nevadas. And we go down, we see our topographic profile. We can see here are our coast ranges, northern coast ranges, not on average as big as the Sierra Nevadas. Then we can clearly see this lowland area, and that's the Sacramento Valley. Very clearly you can see that right through there. So that's going to be a lot of the agricultural area of Northern California is going to be found right through here in the Sacramento Valley. I'm going to go ahead and reset. One of the things we're going to talk about how Northern California, as you go farther north, as you go farther north from San Francisco, you're going to see less likelihood of earthquakes, but more examples of volcanic activity, which we'll also see in the Pacific Northwest. And so there's two particular shapes I want to look at. First off, this one right through there. So it has a certain shape. It has this conical shape and very much shaped like a volcano. So here is an area that actually has a volcanic activity, and this physical feature has been created from that. Let's go up to Mount Shasta, right next to Weed, California. And so kind of an apropos name, and once again we see a very conical shape. A dead giveaway here that we have a volcano. And so volcanoes are formed from subduction, different way, different plate tectonic movement, a boundary than we find in the southern part of the state, or the rest of the part of the state, in which it's more of a transform fault, in which you have plates sliding by each other. And so we're going to see different physical features created from that. In the case of Northern California, extreme Northern California, we're going to see more volcanic activity. And this all essentially blends in up with the Cascade Mountains of the Pacific Northwest. We'll go over here to San Francisco, kind of go ahead and reset our particular profile, and we'll go from right through here, go right through San Francisco, try to go through Sacramento, and go to the Sierras. And once again, we can see here clearly now where people live. So here is the Pacific, and then there's a little sliver that is San Francisco. So San Francisco is on a peninsula. Then we have the Bay, and then we have Oakland, and much of the rest of the Bay Area, in which you do see some people living. But all this area here, you can also see how it's low sea level. So once again, if the Pacific Ocean, if the sea level was higher, this would all be flooded. All of this would be essentially underwater. But also, it's been filled with a lot of sediment from the Sierra Nevadas and rivers, carrying sediment. We think about glaciers, all that snow melts and essentially brings with it sediment and all that debris and fills in this huge valley here. Finally, I want to zoom in. I mentioned beforehand how in the northern part of California we have more volcanic activity because of the subduction zone, and all of that I want to explain a little bit more here in this particular chapter. But we'll go to one particular area of the city just north of it, this particular national seashore. I'm going to go from here and to go to there. And actually what we have here is to go down to the topographic profile. These are two different tectonic plates. This plate is sliding by this plate. So all this particular area over here is on a different tectonic plate than over here. So this is the North American plate, where this is a different plate. So here we have a transform fault boundary. So right through here is the transform fault. Now, not often can we see these, but you can actually see this all the way through here is this transform fault, which all this I'm going to explain more in this particular section.